All right, discrete and indiscrete energy, right? Okay, so this is E equals hf, so this is the energy of a photon, right? This is photon energy. Okay, so this is the energy of the photon. And in this case, it'll be in joules. We almost never want it in joules, but there it is, right? And then this is our 6.626 times 10 to the minus 34th joule second. That's Planck's constant, or Planck's constant, okay? And then this is the frequency. Now, you know, this is great, only we never want it in joules, and nobody ever knows the frequency of like light waves or something like that, right? So typically we deal with wavelengths, right? So there is a relationship between frequency and wavelength. C is f lambda, okay? So that is one of the four formulas. That is 421. Okay, this gives me a rash because I think they should say velocity is f lambda, right? But in this case, it's actually, the c is the speed that it goes, right? So this, this works really well for us here in this one situation, right? So frequency, therefore, is, what is frequency? Frequency is c over lambda, right? And so if you plug that in, you can say E is hc over lambda, and then, of course, you can solve that. That's what this is just solve that for E. E is lambda is hc over E. So this is to find the wavelength of something that has a particular energy, okay? Now, you can, of course, put Planck's constant in. The speed of light is 3.00 times 10 to the 8th meters per second, right? That's just fine, and you can do this and this, right? But also notice that in the front, okay, they've got unit conversions and stuff. Okay, so I'm looking at unit conversion, and this is on page 3. Okay, if you look on page 3, unit conversion 7. Okay, unit conversion 7. If you look at that guy, okay, they say HC equals 1.99 times 10 to the minus 25th joule meters. Are they telling us that if you multiply H by C, you get that in joules? Yes, they are. So that's a shortcut. You can just plug that in, right? Okay. If they give you joules, but almost always we want electron volts. So HC is also 1.24 times 10 to the minus 6th, and that's electron volts instead of joules, electron volt meters, right? Okay. And the difference between this and this is a factor of 1.602 times 10 to the minus 19th, right? Okay. So this is very, very handy. If somebody says that you've got 112 nanometer light, what's the energy of it in electron volts, which we're doing all the time. Remember, its wavelength is hc over lambda. So it's 1.24 times 10 to the minus 6th electron volt meters over 112 times 10 to the minus 9th meters. Right? And then you'll get an answer, and it'll be in electron volts, which is exactly what you want. Anyway, that's what that's for.